we are back with the OV7670 cam, and right now with a LCD display and a battery together with a DC converter and a 5-volt regulator. So we got a output of 7.5 frames per second. And let's see this on the oscilloscope. Okay, so let's first connect the ground with the board. And let's take a look at the LED that is indicating the frames. So every time it toggles, it means there's a new frame grabbed. Okay, so as we see, it's 3.9 Hz. Okay, so now it's 3.75, so this is exactly 7.5 frames per second. So the every time toggle, every time a new frame. So okay, now let's do a little bit of modification to the project. Okay, so now let's disable the power and connect the USB. By the way, when you're using the cam together with the USB, make sure that the data lines are not connected, because if they are, there's some noise on the PIO and it reads glitches from the cam. Okay, but now let's reprogram the board with a little bit of overclocking. Okay, so now let's go into the configuration of the clock, and instead of the PLL multiplier, let's say it's 18 instead of 14. Let's compile. Oh, by the way, don't forget to change the frequency here. So now it will be 108. So this will be displayed on startup. Okay, now let's flash this into our board. Okay, so now let's just power up our supply. And now we get a faster frame rate. But how fast? Let's take a look at the oscilloscope. Okay, so again, the ground for reference, and now let's take a look what we got on the LED. So how fast we are grabbing the frames. Okay, so now it's something like maybe up to 10 frames per second, something like this. Okay, but we can do a little bit of a trick and make more. So let's go back. So now the camera is running constantly outputting frames, but we can do a trick, and every time we are done with grabbing the frame, we can disable the camera. So the moment we are done with printing it on the LCD, we will turn the camera back on. So it will take another photo instantly. So let's disable the power, connect the USB. Okay. And let's do a bit of reprogramming. So I'm taking you here, and let's take a look at the function that I got for grabbing the frame. So it is right here. So at the startup, we enable the camera by the power down pin, and as we are done with taking the frame, we set the power down pin, so we disable the camera. Okay, so let's compile this and flash it into our board. Okay, now let's just simply disable this and enable the power. Sometimes there's a glitch that one side of the screen is brighter and the other one is darker, but we can just simply take another reset and it will be fine. And right now we got something like 15 frames per second. Sorry, the camera that I use is a bit of glitching with the LCD. Okay. So now let's take a look at this at the oscilloscope. Okay, again, ground. And now let's measure the frequency on the LED. So it's something up to 15 frames per second. As you see, so you can see the most of the movement pretty clear. Okay, so now let's take a look at the code that we got for the camera. Okay, so we are at our project, the main file. So let's start at the top. So we got includes for the screen. The files for the screen and the functions are the same as in my previous video, and with some adjustments. So let's take a look at the include file. So right here you have to select the pixel dimension of your screen. My screen is a little bit with an issue of addressing, so in order to fill up the whole screen I had to add 2 pixels by height and width, so a little bit of accommodation for this. And don't forget to select the correct pins for the backlight, and C file you will also have to add the correct pins for the chip select, the data command pin, and there's also, I suppose, at the bottom here, the reset pin. Oh, by the way, it's not used right here, but you can re-enable it simply by uncommenting this. And don't forget to put the correct pin. Okay, and also add the conf of the screen. I also selected 50 MHz clock for the LCD, and this works fine. Also the same definitions for the pins that you are going to use with the screen. I will make a comment in the description how to connect the screen and also the camera. Okay, so as we got this, let's go back to the main file. Okay, so we will have to use the timer 0 for the clock for the camera, the main clock. Here we got some stuff for the screen. Right here I got a buffer to print a line for the screen, so it's 160 pixels. That is not used. And this is the stuff for the SPI. Those functions are not used because there's no touch for the screen. It's just a simple display. So this function also is not used. This function is used to set the background, and that's for printing charters. The charters are in the fonts.h, and they are like so. So this is A. You can add your own and put them right here for printing. Okay, now this is a function for printing a string of charters. So next on, this is the display start function. It makes an init for the display. Although it's for the ELE9341, it also works with the ST displays. So right here we got printing of the text, and the background is set right here. So this is not true for my display, because in my display it's a bit of a swap, because the first one is the blue pixel and the middle one is the green. Okay, now after that we got the section for the camera. So right here we got the pins that are used for the camera, and this is the pin numbering on the Arduino board, so it's a bit easier. I will do the same for the LCD and put it in the description of the video. Okay, next on, the pointer to the POC data for the pixels. This is not used. It was a bit of an assembler approach to read the data, but finally it didn't matter if I used the normal C approach or the assembler, so this can be deleted. Okay, next on, some definitions for the functions below. But okay, now the timer configuration. So this is configuring the timer to run about 20 something megahertz. By theory it should work by something like 24 or something, but it's missing a few megahertz. However, the speed can be also multiplied in the camera. So we configure the timer and start it. Next on, we got the function for the pins that are used in the camera to configure. So again, this is the pin that is used in the clock for the camera. So it is the D2, and it's used by the timer peripheral, and it has to be set like this. Okay, and those are the 2-wire interface for the camera, the reset and power down pin for the camera, and also the data pins, the synchronization pins, and the clock for the pixels. And they have to be configured as default, because changing that to glitch or something else just makes the input slower. So that worked for me the best. Right here I got a function to check that I got the pin set, so it works a bit faster than the default function. Next on, we got the function that is used to grab a frame. So right here I got the modified version for the 15 frames per second, and the frame format here is downscaled by 4, so it's 160 by 120 pixels. So at the start we check for the vertical synchronization to start, and then we go through the pixel rows, columns. So we got 160 columns and 120 rows, and in my configuration I read the second falling edge, so this is the pixel data here. And after everything's done with the reading of the frame, I disable the camera with the power down pin here. Okay, now the configuration of the two-wire interface. So we set up the address of the chip, the camera, and we also make sure the interface of the two wires enabled. So in my instance it's the TWI1, and we write here the configuration for the camera. Also here are some registers for gain and other stuff, which I will talk about at the end of the video. And here is the most important register that we have to write, because this is the divider for the pixel clock. So how fast we can get the frames. So in my opinion this is the most of the speed that we can achieve here. Okay, and here we got the displaying of the frame, a simple function. So we simply take the whole line and we put it in buffer, and next on we print it to the screen, and we go through the rows, so 120 times. Okay, so the main function here. So the regular setup here, the PIO instances are powered up here, and the pins for the screen and also the LED are set up. This is the USB starting up. We actually don't use it here, but it is anyway. We can uncomment it. Commit. Okay, so the display is here configured, and the camera pins are configured. Timer is started, and now the registers are written to the two-wire interface. Okay, so in the main loop that we got here, the first thing we do, we toggle the D13 LED, then on we get the frame, and as we got the frame we print it to the display. So this is it. And this is how you get 15 frames per second. So I hope you find it useful in your projects, and see you in the next one.